Okay, we've got a question about pie charts, which in your booklet are cunningly printed in identical shades of grey. Actually, if you look carefully, you can see where the lines go, but I would do what I've done if I were you and draw in the cut-off point, so actually you can see what you're supposed to be seeing. So, okay, we've got a survey taken on a Monday morning about colour of cars in the school and entering the school, and also the same thing for a Friday morning, and for some different reason they're completely different, and purple cars are dead popular for some reason. Oh, I must have missed out a slice here for green. There we go. Alright, okay. So, alright, I suspect this data is being made up, because I don't think the blue percentage would change that radically. Can't think of a reason for it, but never mind. Let's take it at face value and think about how many green cars entered the school on Monday morning. So I can see that 30% of the cars were green, and so I just need to actually find out how many that's out of. So have I done all my reading? In total, there are 80 cars entering on the Monday morning. So therefore we need to do 30% of 80. So 30% of 80 equals 0.3 times 80, which is 24 green cars. Lovely. Okay, and then it is claimed that more blue cars left the school on Friday evening than entered on Monday morning. Okay, well, if we look at the diagram, more blue cars on Friday evening than Monday morning. Oh, it's Friday evening rather than, okay, even so. Well, I can see the percentage is much higher, okay, but what does it say? It doesn't say a higher percentage. It says more blue cars leaving the school on Friday evening. So what I don't know is, and what I haven't got is anything to compare with that 80 cars. Okay, although it was 50% of the cars leaving at that time on Friday, this might be a much smaller number of cars in total. So I can't say that in number terms there were more blue cars leaving on Friday evening, because if there were only 10 cars altogether leaving on Friday evening, then 50% of 10 is going to be a smaller number than 25% of 80. Okay, so we can say that although there was a higher percentage of blue cars leaving on Friday evening, the actual number may have even been smaller. Okay, so although there was a higher percentage of blue cars on the Friday evening, we don't know the total number of cars, so we can't know how many blue cars that higher percentage was. Okay, now because we've got side-by-side pie charts, it would be good practice actually if this was on Friday evening, if this was this should say Monday AM and this should say Friday PM. Okay, so that's one problem with the diagram. If you're commenting on this, you'd say that the titles aren't adequate. The other thing that you can make on this is that really, if these were different totals numbers of cars, then that should be reflected in the size of the whole. So each whole is divided up into the correct percentages, but if this whole represents a smaller number of cars, then the circle should really be smaller with its area in proportion. That's called proportional pie charts. They're not specifically on the spec, but it is a way that the impression could be misleading. This is giving the impression that on Friday there are a similar number of cars than on Monday. That may not be true.